This is Professor Derf Seitz. This Java tutorial is the second in a series that introduces object-oriented programming through an example random numbers game. This is a class diagram that shows the relationship between all the classes that make up the program. Classes are these boxes. Every one of these boxes is a class. A class has three compartments: a name compartment, a data compartment, and a function compartment where the methods or operations, those are all synonyms, operate on the data. The idea with a class is to hide the data from outside use so that the implementation of the class is hidden. The methods or functions, which are synonyms, I'll use functions. The functions that are available use the data, use the implementation of the class, but outside users don't know anything about how the class is implemented internally. That way, when changes need to take place, they can take place without impacting the clients of the class. We're only showing in this diagram the functions and data that are pertinent. These classes down here in the Java class library have many more, and they have three compartments as well, but we're not showing all the details. Object-oriented programming involves objects. How do classes relate to objects? A class is like a rubber stamp. When you put some ink on it and stamp it, it makes an object. So a class can be instantiated into more than one object. The classes themselves are the architecture of the program. The objects are what run during the execution environment. Here we have some layering as well. Here's our program class right here. It's called Random Number Game, and there's a client of it over here, Random Number Game Client. That's our application, and our application has to use classes in the Java class library, and these relationships show how those classes come into play. The dashed lines indicate a usage, a class using another class. These solid diamond things here represent a part. The system class in the Java class library contains a print stream and an input stream with the names in and out, in being the input stream and out the print stream. So we see here the big picture. It's important that we can conceptualize and have a view in our mind of what the program's doing. If we're just looking at the code and we don't see this picture, we're not going to be able to understand what's going on. We will zoom in to see a closer view of these classes momentarily. Let's just name them. We've already named these two up here. In the Java class library, there's the math class, the string class, the system class, scanner, random, and system we've mentioned has print stream and input stream. String is an example of a class where in the runtime environment there will be multiple strings in use, whereas the random number game class up here in the runtime environment will only have a single object to represent it. Looking closer up at the random numbers game class, here again in red is the data, and here in green are the functions. These symbols to the left represents their access. A minus sign is private. They are not viewable from outside the class. The plus signs are public. They represent the API of the class, the application programming interface. It's only through the public functions that other classes make use of the class. And of course, remember, in the runtime environment, we're talking about objects that are doing this interaction. let's look at some of the public functions of the random numbers game. It has one here with the same name as the class. That's called a constructor. In fact, there's two of them. One that takes no parameters and another one that takes a cost per spin and the spin base winnings. Those functions that have the same name as the class are called constructors. They're the ones that are used to create the objects. It's called instantiating the objects. We'll see that in part 3 when we look at the code. The new keyword in Java is what's used to instantiate an object from a class. Getting past the constructors, there are some get functions. Get cost per spin, get game winnings, get spin base winnings. These are called accessor functions or simply getters. They allow the data, that the internal representation that's private for certain fields, these are also called fields, the data, to be obtained by another class. So another class can get the cost per spin. Notice there's no set functions in this class. You could have set functions. They're called mutators. They change the class. They allow an outside client of the class to call it, pass a parameter, and change one of the data values. However, to have maximum encapsulation, maximum data hiding, minimize the use of setter functions. Also, there's a function here called play that initiates the play of the game. These other functions here are private. They're helper functions that are used by the public functions in order to do the job. They're not exposed through the API. They're only for the internal workings of the class. The data and the functions collectively are referred to as members of the class or members of an object. Members that are underlined in a class diagram, such as down here and up here, are static. Static members can actually be called or used without having an object. All you need is the class name and then the member name to call them or access them. For example, in the random numbers game client, there's a main method. We've seen main before in our basic applications. That's where the program starts running. Down here in the math class, there's an absolute value function that is called, and it's static. We don't need an object of class math. We only need to say the math class name, and then we use the dot operator, a period, and then the function name to actually call the function, and we don't need an object because it's a static function. System has two static members, in and out, and they're parts of it, and so you can get at these other functions down in the print stream by calling system.out. For example, printline. Printline is a public function of print stream that prints out a line to the system console. Our random numbers game class will use system, the print stream and the input stream, to obtain data from the user through the system console and to display data back, messages back to the user. Scanner is used to get the information from the system console. Scanner makes use of an input stream, and we'll be using the next line function of it to get back an entire line of what was entered by the user. We'll be using the random class as well for our random number that we use for the digits in the spinner and also for the bonus amounts. It's also important to understand that when you call functions, you have to look at their API at what's called their function signature. For example, calculate winnings is a private function inside the class, and it doesn't take any parameters at all. But generate random number, which is also private, takes a begin and an end to get a random number within that range. Looking at the public functions, there's get cost per spin. You see the parentheses there, and there's nothing inside the parentheses, so there's no parameter necessary to pass to that function. You just use the object name dot this function name and then the parentheses. However, the constructor here, the second one, does take some parameters, so it's important that when you use functions you call them exactly as specified by their signatures. Looking again at the whole class diagram here, we can see that the main method in our client is going to make use of our random numbers game class. It will also make use of math, string, and system. Our main class here, random numbers game, will make use of system, scanner, and random. And in the next part of this tutorial, we'll be looking at the code of these classes, random numbers game in particular, and the client, to get into more details. But you can see how without this big picture it would be futile to go in and look at the code because you wouldn't have a clue what was going on.